Good morning, everybody. This is David Allgood with the California Air Resources Board. Thank you for joining the webinar today, titled Meeting California's Carbon Neutrality Goals, Approaches for the Industrial Sector. I'll be starting in just a moment. Thank you very much, and we'll be starting this webinar now on the approaches for the industrial sector. I'm David Allgood with the Cap and Trade program. My focus is on industrial allocation and benchmarking. Today's webinar will be a continuation of our series of public meetings on carbon neutrality and our second presentation on the industrial sector's contribution to California's carbon neutrality goals. This webinar is presented live on California's EPA video website, and a video recording will be available on CARB's Scoping Plan meeting page. I will not be taking live questions today, but we encourage you to submit written comment on our webpage by Friday, March 6th. This slide shows California's long-term climate goals. We have some key statutes and executive orders that guide the state's climate targets. In 2006, AB 32 set our 2020 target to return to 1990 greenhouse gas emissions level. Then, SB 32 called for 40% below 1990 levels by 2030. CARB's 2017 Scoping Plan lays out a cost-effective and achievable path to this target. This 2030 target is on path to achieving the goal of reducing greenhouse gas emissions 80% below 1990 levels by the year 2050. Both last year's executive order calling for carbon neutrality by 2045 and the climate science require us to find ways to reduce greenhouse gas emissions from fossil fuels at all opportunities. This also emphasizes our need to focus on our natural and working lands and other sequestration opportunities. Carbon neutrality will require mitigating greenhouse gas emissions at their source, increasing carbon sinks, and moving towards non-combustion scenarios in the future. Our thinking about how to approach the climate challenge is evolving, and carbon neutrality is gaining importance. This concept is that to address climate change, the carbon dioxide and other greenhouse gas emissions generated by sources such as vehicles, power plants, and industrial processes must be less than or equal to the amount of carbon dioxide that is stored. The magnitude of the climate change impacts will depend on when carbon neutrality is achieved. The latest science tells us that we need to reach global carbon neutrality by mid-century and indicates that on a global scale, some regions may remain net emitters while others are better suited to be net sinks. In California, we have an executive order that calls for carbon neutrality by 2045, which is consistent with the IPCC report. This executive order introduces the concept of balancing carbon emissions and carbon sequestration within the state. Part of moving towards this balance is reducing fuel use at sources throughout the economy to the maximum extent feasible. In the industrial sector, fuel combustion is tied to a wide range of applications, and eliminating fuel combustion won't always be practical. CARB is evaluating approaches to deep decarbonization while recognizing the importance of the industrial sector to local jobs and the statewide economy. The path to carbon neutrality requires actions on both sources and sinks, As we approach carbon neutrality, we must begin thinking about moving past combustion at all possible areas. Any fuel combustion leads to local air quality impacts, and CARB continues activities to reduce air pollution and improve public health. In the long term, we recognize that moving beyond combustion won't be feasible everywhere, but where it is possible, it will support both our climate change goals and our air quality goals. Today, we track statewide greenhouse gas emissions from transportation, electricity, commercial, residential, industrial, agriculture, and waste management sectors, including high global warming potential gases. We also track emissions and sequestration from our natural and working lands. Currently, these lands are a source of greenhouse gas emissions, releasing more carbon than they are sequestering. Some emissions from this sector are part of the natural cycle and are necessary for healthy systems, including emissions from periodic fires. To achieve carbon neutrality by mid-century, we must minimize emissions from our fossil fuel energy and industrial sources and transition our natural and working lands from a source to a sink. As we start to consider the concept of carbon neutrality, our starting point is at CARB's existing accounting framework, which includes all major greenhouse gas emissions, not just carbon dioxide. Over the past year, CARB has held a series of meetings on carbon neutrality listed on this slide. Carbon neutrality in the California context, the role of the industrial sector, scenarios for deep decarbonization, social cost of carbon and affordability, and most recently, carbon capture, sequestration, and options for utilization. More information on these meetings can be found on CARB's Scoping Plan Meetings webpage. CARB held a workshop on the role of the industrial sector in carbon neutrality in July 2019, and this webinar is a follow-up to that discussion. The workshop last July consisted of two panels, one on economic considerations for emissions reductions and one on the technologies to decarbonize industry. I've included some of the key takeaways from this workshop on this slide. Current technologies may not result in sufficient emissions reductions needed to decarbonize industry. Current prices of renewables and electricity need to decrease to warrant large-scale switching to these technologies. And since we don't know what actions might unlock future low-carbon pathways, we need to take an all-of-the-above approach to target greenhouse gas-reducing opportunities. California needs strong policies in place to drive deep decarbonization in industry, and any of these policies need to minimize leakage and recognize the importance of industry to jobs and the economy. Today's webinar builds on these key concepts, and I will review the technology and policy options that we have considered by experts. I will provide some context by giving an overview of the current California regulations for the industrial sector, and I will review several policies and incentive mechanisms that other jurisdictions are using to address industrial emissions. I'll finish by teeing up some questions for everyone to consider when you're submitting comments. The technology panelists from the July workshop identified this potential suite of options to work towards industrial decarbonization. Process changes and efficiency gains, such as membrane technologies or other novel approaches, new sources of process heat, such as electric boilers or solar thermal heating, renewable fuels, such as renewable natural gas, green hydrogen, and biomass, carbon capture, sequestration, and utilization was also identified as a viable option for industry, but CARB held a workshop exploring these potentials of CCUS last December. Next, I want to go over some policy and incentive mechanisms that may be available to help spur faster transition to these technologies. This is a high-level infographic from McKinsey & Company showing how different policy mechanisms may be appropriate for incentivizing uptake of different decarbonization technologies, depending on the level of technology maturity. The top describes the technology readiness along the range from research to development to widespread adoption. The middle shows where industrial technologies fall within the technology readiness levels. And the bottom shows the general policy approaches likely to be appropriate based on technology maturity. This graphic highlights that different policies may be more effective at certain levels of technology readiness. For example, grant programs and subsidies may be best to push technology innovation during the research phase, while regulations may be more effective for promoting adoption of mature technologies. This is a fairly comprehensive suite of tools to decarbonize industry, and this list is adapted from the ICEF report at the bottom. The numbering corresponds to the presentation in that report and does not indicate any preference or priority. Options include government-funded research and development, such as through the U.S. Department of Energy, government procurement, such as the Buy Clean California bill, fiscal subsidies, such as grants and loan, infrastructure development, such as accelerated permitting of renewable electricity transmission, carbon pricing, such as through the cap-and-trade program, carbon tariffs, such as border carbon adjustments, mandates, such as direct regulation for emissions reductions, voluntary associations, such as the implementation of the ISO 5001 standards, and participation in clean energy forums and other information sharing programs. California's comprehensive suite of policies for reducing greenhouse gas emissions already includes many of these tools, but CARB's Board Resolution 1746 is directing us to continue to evaluate and explore opportunities to achieve significant cuts in greenhouse gas emissions from all sectors and sources. So more options for decarbonizing industry may be needed, and we need to explore which options may work to move California forward. Over the past decade, California has adopted and implemented a suite of measures to reduce industrial emissions. The California Cap-and-Trade Program, the LCFS regulation, the Oil and Gas regulation, and the Regulation for Energy Efficiency and Co-Benefits Assessment of Large Industrial Sources are measures that cover the industrial sector. And while we continue to seek further greenhouse gas reductions, it is important to recognize the state's long history of adopting health-based air pollutants. California's air quality programs are responsible for significant public health improvements through statewide and regional air quality planning requirements, advancement of technology-based solutions, and risk reduction efforts near industrial facilities. However, certain communities continue to experience environmental and health inequalities from air pollution. CARB is in the process of implementing AB 617 through the Community Air Protection Program, which is providing a community-focused action framework to reduce air pollution and improve public health in communities most impacted. There are also incentive mechanisms in place to encourage industrial greenhouse gas reductions. The Cap-and-Trade program is designed for compliance flexibility to minimize costs, and there are also free allocation to industrial facilities to minimize leakage, because relocation of industrial production, that is a shift of emissions from inside the state to outside of the state, without the benefit of actually reducing overall emissions, does not have a global greenhouse gas benefit. The California Cap-and-Trade Program auctions raise proceeds that are reinvested in programs that further the goals of AB 32 through the California Climate Investments. An example program is a food processor investment program, which provides a total of $120 million to food processors. This was first established in the Budget Act of 2017 and had to continue funding through 2018. It provides grants to two different tiers of projects. Tier 1, drop-in technologies, like upgrades to boilers and refrigerant systems, and Tier 2 is for emerging technologies, such as solar thermal steam generation and microgrids. There are also incentive programs, such as PEER and EPIC, aimed at reducing industrial greenhouse gas emissions through financing of equipment upgrade, energy efficiency programs, and custom rebates. The Refinery Investment Credit Program within the LCFS provides credits to projects that reduce greenhouse gas emissions at refineries. This is an incentive program that operates within the LCFS regulation, where refineries may receive LCFS credits through an application and approval process. CARB has started receiving applications for this credit, including one to electrify a gas turbine compressor and the other one to for improvements at a catalytic cracking unit. CARB could potentially explore other mechanisms to incentivize industrial actions that operate within existing programs, using this LCFS refinery credit mechanism as a general model. We expect that decarbonizing the industrial sector will be challenging, but California isn't alone in looking to decarbonize industry. Other jurisdictions around the world are working to do the same thing, and they're taking a variety of approaches to dealing with the hurdles and constraints that everybody is facing. Some challenges will be specific to certain jurisdictions, while others will be more universal. I now would like to spend some time discussing the incentive mechanisms and tools being implemented in other jurisdictions in order to better understand how others are thinking about this challenge and how they have dealt with it. The mechanisms that I'll discuss are already up and running, and therefore represent viable approaches for at least some jurisdictions. I'll step through some measures from the European Union, Canada, New Zealand, Australia, and Tokyo, and as I do, I encourage you to consider how programs or elements of programs may translate to the context of California's industrial sector. For many of the slides, I'll be using this technology readiness chart on the right to identify what types of projects are eligible. The right side of the graphic shows a level of project maturity from laboratory proof of concept to pilot to demonstration, scale out, scale up, and roll out. On the left side of the graphic, the programs are identified as they relate to certain technology readiness levels. The next three slides that I'll discuss are European programs. The Horizon Europe for research and development pilot projects, the Innovation Fund for pilot, demonstration, and scale-up projects, and the EU Investment Bank and InvestEU's financial support for project scale-up and adoption. This slide covers the Horizon Europe program, which has an objective of advancing early-stage research and innovation. The first phase of Horizon Europe, Horizon 2020, had a budget of 77 billion euros starting in 2014 and ends this year. 17 billion was specifically earmarked towards advancing industry. The EU completed an interim evaluation of the Horizon 2020 in the year 2017. This evaluation identified challenges with Horizon's 2020 coordination between other funding sources. The EU also noted that Horizon 2020's budget had funding only for 1 out of 4 proposals that were evaluated as high quality. As of the 2017 interim evaluation, the EU would need to provide an additional 66 billion euros to fund all of these high-quality projects. The EU has proposed that the Horizon Europe program run from 2021 to 2027 with a funding level at 94 billion euros coming directly out of the EU budget. An example industrial project was a cement plant in Belgium that received 12 million to install carbon capture technology to mitigate process emissions. Importantly, this funding built relationships between a broad consortium of cement companies, academics, nonprofits for future low-carbon cement projects. Members of this consortium are now working on an oxy-fired cement kiln to improve fuel combustion efficiency. This slide covers the second in the European Union programs. And this slide will cover the Innovation Fund that will run from 2021 to 2030, and its predecessor, the NER, New Entrant Reserve 300, which started in 2013 and concludes this year. These programs target innovative technologies that are proving initial commercial viability and can reduce the emissions in the European Union's trading program, the ETS. The EU funded the NER 300 by auctioning 300 million allowances, and this program was limited to specific project types, including renewable energy, biorefineries, and electricity generation with carbon capture and storage. The project applicants only received these payments after the project was completed and emission reductions were verified. This delayed the availability of funds and made capital-intensive projects difficult to develop. In the end, no CCS projects were funded and only 2 biorefineries were funded, and many of the other projects were for renewable energy. One example was from the Vercelli cellulosic ethanol plant, which was a first-of-its-kind plant that received 28.4 million euros in NER 300 funding and additional funds from the Italian government. Recognizing that NER 300 program had limited uptake beyond renewable electricity, the EU conducted an internal audit and solicited stakeholder feedback and opportunities to improve the post-2020 program, which would be called the Innovation Fund. Stakeholder feedback led to several changes for the Innovation Fund. Grants will provide 60% of the total project, up to 60% of the total project cost, rather than 50%, and the fund will be dispersed over half of the awarded money before the project completed, based on predefined milestones. All innovative project types at covered industrial facilities are eligible, and they'll be ranked based on estimated cost per ton of emissions reduced. The total size of the Innovation Fund will be approximately 10 billion euros. This slide discusses the 2 EU financing programs that incentivize scale-up and commercialization of projects. Banks can be hesitant to loan projects that they view as too risky. To remedy this and get more projects approved for lending, InvestEU provides loan guarantees for low-carbon technologies. This stimulates private capital and lowers interest rates. The program is partially funded by the EU budget and partially funded by the European Investment Bank, or EIB. The EIB loans money to private companies for many types of large projects, including low-carbon technology projects. The EIB loans can have a subsidized interest rates for low-carbon projects, but have high standards for the credit worthiness of each borrower and the financial viability of each project. An example project receiving these loans is a Finland bioproduct mill, which is the largest wood processing plant in the Northern Hemisphere. This facility produces 1.3 million metric tons of pulp each year, powered entirely by biomass. The facility also produces bioproducts such as oil and gas and exports its green electricity. The total facility cost was 1.2 billion euros, with 275 million from an EIB loan and $75 million in loan guarantees from InvestEU. We'll now be transitioning into Canada's projects. This slide is on the Strategic Innovation Fund, which provides 10 to 50 million Canadian dollars to 5 different funding streams, which includes research and development, business growth and expansion, to attract and retain large-scale investments, advance industrial technologies, and national innovative ecosystems, which are partnerships between corporations and Canadian universities. Most of these streams accept applications on a continuing basis with no deadline, but the industrial technology stream is a competitive grant program. Contribution is determined by a review committee, whether that's a grant, government loan, or both. One interesting aspect of this program is that there is a large amount of funding earmarked for the steel and aluminum sectors to modernize these facilities and better integrate the supply chain for these sectors. The program as a whole funded over 2 billion Canadian dollars and leveraged over 43 billion in total investments and created an estimated 67,000 jobs. The Emissions Reductions Alberta program is a grant program that started in 2009 to accelerate development in innovative technologies and transition Alberta to a low carbon future with a diversified economy. Emissions Reductions Alberta uses a call for proposals process to target specific needs. For example, there was a 2018 challenge called the Methane Challenge and a 2019 Industrial Efficiencies Challenge. This type of framework is similar to what the CEC uses in its grant funding opportunities, but generally is more generic. For each challenge, the total amount of funding varies, as do specific terms and cost-sharing requirements. The application process is divided into two stages. The first is the expression of interest stage, followed by the full project proposal stage. Successful applicants then enter into a contractual agreement that outlines details such as the project scope, work plan, deliverables, and terms of funding. Each of the projects must regularly submit reports on progress. As of today, Alberta has provided 565 million Canadian dollars to 165 projects, with greenhouse gas emissions reductions estimated to be 41 million metric tons of CO2 through 2030. Within the industrial sector, there were several distinct funding opportunities for industrial efficiency, and 70 million Canadian dollars has been awarded to 11 projects. An example of one such project is a $6 million grant for flue gas recovery at a pulp mill. The Clean BC Industrial Fund is a British Columbia program that will be opening its request for proposals this year. Its aim is to invest a portion of its carbon tax into innovative projects to reduce industrial emissions. More than $12 million has been committed towards this program in its first year, and these funds are available only for industrial facilities that are covered in their carbon tax program. TechnoClimate is a grant program to support innovative and energy efficiency and GHG emissions reductions that is administered by Quebec using their cap-and-trade auction proceeds. This program is scheduled for one round of grant funding, and the applications were due in November of 2019. Grants are limited only to industrial facilities covered in Quebec's cap-and-trade system. The funds are available for advanced technologies or pre-commercial technologies that are not currently used in the industrial sector. Grants are available up to 3 million Canadian dollars, with the requirement that this funding may cover up to a maximum of 50% of the eligible expenses. The Low Carbon Economy Challenge is a program by the federal Canadian government that is scheduled for 2 rounds of grant funding. This project is geared for small to medium-sized projects with a requested contribution in the range of 20,000 to 250,000 Canadian dollars for commercial-ready applications. Grants are available to cover up to 25% of total eligible costs. A total of 40 million Canadian dollars is available for applications that was due in March 2019, and the second round of 10 million Canadian dollars was available for applications due in November 2019. So more information about this program will be available soon. Eligibility includes a broad range of sectors, from buildings to industry to electricity generation, and instead of being sector-specific, the main specification is that the technologies implemented must be proven technology, so a high technology readiness. The projects are evaluated by a cross-disciplinary review committee comprised of federal officials and expert reviewers who judge applications by a combination of risk, feasibility, and cost per ton of federal dollars invested. The total funding for this program is $50 million. The Energy Efficiency and Conservation Authority, EECA, in New Zealand implements programs supporting reductions in energy use and greenhouse gas emissions for large energy users. The Technology Demonstration Subsidy supports investments in proven but underutilized technologies for process improvements. This program subsidizes up to 40% of a project cost and up to 250,000 New Zealand dollars. Companies apply by submitting a demonstration project plan. To qualify for this funding, project must reduce energy intensity and greenhouse gas emissions, be applicable to multiple businesses in a sector, and also must be financially viable. Recipients must commit to having the project independently monitored. New Zealand also subsidizes a system optimization for existing processes. The system optimization subsidy is available to commercial and industrial sites that spend at least $200,000 on energy costs. To qualify, a project must deliver a guaranteed level of energy savings, but generally, project payback must be longer than at least 2 years to be funded. In Australia, the Australia Renewable Energy Agency, ARENA, implements Advancing Renewables Program, which is a grant program to support a broad range of development, demonstration, pre-commercial deployment projects that can deliver affordable and reliable renewable electricity. For the industrial sector, ARENA focuses on alternatives to fossil-fueled process heating that have potential to be applied to multiple sectors. The focus is on key technologies such as solar thermal, renewable energy, and energy storage. Grants are expected between 100,000 and 50 million Australian dollars, and applicants are expected to at least have full grant funding, or at least match the grant funding in their private funding. The program prioritizes information sharing, and any grant recipient must agree to a negotiated knowledge sharing plan to cover this project development, implementation, and outcomes finding. The extent to which this data may be made publicly available or provided confidentially to ARENA must be detailed in the sharing plan. So a lot of public information is generated through these projects. An example project is a fuel switching project at a canola oil plant that replaces its gas boilers with biomass. This project will reduce approximately 80,000 metric tons of CO2 over the life of the project. This project costs about $5.4 million, and it's approximately half of that was from an ARENA grant. In 2009, the U.S. Department of Energy started to provide financing for low-carbon energy and auto manufacturing. The DOE provides 2 types of financing. First, DOE provided loans to companies deploying new technology that are not attracting commercial loans. And second, DOE provided loan guarantees to encourage commercial lending to innovative projects. If a project fails, did DOE promise to pay some or all of the remaining loan back to the commercial bank? As of 2018, the overall project portfolio has paid DOE $3 in loan interest to every dollar that was lost on an unsuccessful project, making it a fairly successful overall program. The portfolio has also resulted in an estimated cumulative emissions reduction of 50 million metric tons of CO2 through 2018 and spurred additional commercial lending. An example of commercial lending following this program is the role it played in spurring the growth of U.S. utility-scale photovoltaic solar facilities. Prior to this program, there were no solar PV facilities larger than 100 megawatts. The DOE provided loan guarantees for the first 5 utility-scale projects to exceed 100 megawatts. Within the next 5 years, commercial lenders financed an additional 17 projects without DOE support. These next 2 slides discuss energy management standards. The Tokyo Cap-and-Trade program incentivizes implementation of energy management practices at industrial sources by providing additional reduction credits to what they label as top-level facilities. The Tokyo program includes facility-specific emissions reduction targets, which is a design very different than the Cap-and-Trade program, which is more flexible. Facilities may get certified as top-level facilities by implementing a long list of energy management practices and achieving outstanding emissions reductions. Top-level certification then lowers a facility's emission reduction targets by half. For example, if a target was 17%, a top-level facility may only require an 8.5% reduction from 2015 to 2019. This allows top-level certified facilities to earn more emissions reduction credits, and then these can then be sold or banked. Certified facilities must annually report on compliance within their top-level standards. And I'll give an example of this type of program on the right. The graphic on the right shows how this works. On the top, a standard facility has an established baseline and a target of, in this case, 17% reduction. If the standard facility reduces its emissions beyond that amount, it earns credits that it can then sell and bank for future compliance. If the facility receives top-level certification, then the emissions reduction stringency is halved, and it earns additional credits if it reduces beyond that point. As of 2017, 66 facilities were certified. This is the second slide on energy management standards. The International Energy Management Standard, ISO 5001, establishes energy management standards that can be incorporated to national certification programs. The ISO 5001 provides a framework to help companies continually improve energy performance and reduce emissions, but it does not specify reduction targets. ISO 5001 provides energy management standards for both operational processes and management practices. These international standards are implemented at over 40,000 sites worldwide, with over 80% of certified sites in Europe. A number of countries, including Korea, France, and Germany, provide or have provided financial incentive to assist facilities in implementing the ISO 5001. As of 2018, the U.S. had 59 certificates at 201 sites. Currently, the DOE certifies and recognizes facilities meeting ISO 5001 under its Superior Energy Performance Program, SEP. While a variety of tools, training, guidelines are available from DOE, no financial assistance is provided. The standards under the SEP program have proved successful, with most facilities reporting 3 to 20% improvement in energy performance. For example, over a 2-year period, 3M achieved a 4.2% improvement in energy performance at 13 U.S. sites. This relates to more than 160,000 metric tons of CO2 reduced. I'll now begin to review some of the material that we went over. Again, the latest International Panel on Climate Change, IPCC science, shows that carbon neutrality by mid-century is key to keeping global warming below 1.5 degrees C and meeting this goal requires progress in all sectors, including industry. We're seeing some technical advancements that can help decarbonize industry, but substantial hurdles still remain, one of which is costs. Each year, more jurisdictions are considering and implementing carbon pricing systems to address the climate challenge. As indicated in this presentation, jurisdictions are looking beyond carbon pricing and other incentive mechanisms to spur innovation and reduce industrial emissions in industry. These incentives include grants, loans, loan guarantees, energy management standards, and compliance credit generation, and we've touched on many of these examples and projects. Many programs share common approaches with regard to eligibility of sectors and technologies and the application and approval requirements, but we've also identified some novel approaches related to things like information sharing requirements and other aspects. In California, we have a suite of programs addressing greenhouse gas emissions. Our cap and trade program, which incentivizes greenhouse gas reductions in the industrial sector, also addresses business competitiveness concerns by using free allocation within the program. We need to continue to evaluate and explore opportunities to achieve significant cuts in greenhouse gas emissions from all sectors and sources, including industry. So we've been considering actions in other jurisdictions, and we're looking at what elements and approaches might be useful in California. CARB staff has begun considering what potential additional tools could be implemented to promote further greenhouse gas reductions in the industrial sector. We've looked at reports generated by academics, industry groups, and others. We've assessed the regulations and incentives from other jurisdictions, and we've considered models from within our own suite of programs. We're evaluating how these options might fit into the current California context. The cap and trade program already provides a carbon price incentive, but there may be more opportunities to further incentivize industrial emissions reductions. One potential application of this concept would be set aside a pool of allowances that would be available to industrial facilities for technology upgrades, and this could be based on applications to CARB, reported emissions data, or some other approach. CARB has considered this concept of an allowance set-aside pool within the cap and trade program in the past. And as we consider a much deeper decarbonization needs for achieving carbon neutrality, all of these options are on the table. For example, in March 2009, there were discussions around creating a set-aside pool of allowances for early action emissions reductions in industry. This CARB presentation teed up a number of important discussion questions about how such a set-aside pool could work related to eligibility, timing, and other factors. The crediting mechanism under CARB's low-carbon fuel standard, such as the refinery investment credit and the innovative crude production credit, offer elements of a potential project application model that could be used within the cap and trade program. Another potential option is to create a set-aside pool of allowances available to natural gas suppliers to make renewable fuel use more cost-effective at industrial facilities and to promote decarbonization of the natural gas supply. The panelists at our July 2019 industrial workshop for carbon neutrality identified renewable fuels as one of the options in the all-of-the-above approach. But economics were pointed out as a limiting factor in this approach. By creating a pool of set-aside pool of allowances, this could be an additional mechanism to bring renewable fuels to market and decarbonize industry, especially where this is challenging. Variations on this concept have been publicly discussed and commented on in response to prior CARB workshops, such as in the April 2018 workshop. This slide is only a starting place. There are a couple of initial concepts and not a complete list of potential options. So we're interested in hearing feedback on what these concepts are or variation on these concepts. And we're also interested in hearing your feedback on other programs that we have discussed in this presentation, other ideas, or how elements of these other programs may be adapted to the California context. So we've covered quite a bit of material, and we're seeking your feedback. As you prepare comments, we encourage you to consider these questions. What are your thoughts about programs in other jurisdictions that were surveyed? What elements of these programs might be worth considering in California? What other programs administered by CARB could be leveraged or adjusted to support further emissions reductions in the industrial sector? What hurdles does California face for decarbonizing the industrial sector, and how can CARB help overcome these hurdles? The comment site is now active and will be accepting comments until 5 p.m. on Friday, March 6th, 2 weeks from now. Your comments are valuable to the process of crafting a robust approach moving forward, and we appreciate your time and effort in preparing feedback. This slide is given for resources of some of the reports that we've referenced in earlier slides. And if you're looking for more information on links to these programs in other jurisdictions, this slide has a list of links. And we thank you for joining this webinar. Please provide comments when you can.